Okay, now we're going to go ahead and take a look at growing dots, the 3.1H lesson. And by now you have probably already talked quite a bit about the pattern that you see here. And I'm guessing that at least a few of you noticed that the next figure always has twice the amount of dots as the previous figure. So this has 3, then this has 6, and then this has 12. Some of you may have noticed that each little group doubles. Some of you may have looked at it as these 3, and then those 3 happen twice, and then those 3 happen 4 times. However you looked at it, hopefully you noticed that it's 2 times the previous figure to get the next step. So in number 3, when you are asked to write a recursive formula to describe how many dots there will be after t minutes, remember the first step in a recursive formula is to identify what's happening initially. And in this case, when time is 0, we have 3 dots. So our recursive formula is going to start with f of 0 equals 3. Then we're going to talk about, if we look at what we want, which is whatever the next step is, we're going to look at the previous step, f of t minus 1, so the step before, and we're going to decide what happens there. And in this case, since it's doubling, we're taking the previous step and multiplying it by 2 to get the number of dots in the next step. Again, this is called the recursive rule or recursive formula. So now let's go ahead and look at the table for this. And just like we did in the warm-up, let's go ahead and look at the difference between each step's number of dots. So the difference between 0 minutes and 1 minute is a difference of 3. And then we have a difference of 6 between 1 and 2 minutes, then a difference of 12 dots, then a difference of 24 dots, and so on. This is not a constant as it was with our warm-up. So what does that mean if it doesn't have a constant difference? This is not an arithmetic sequence. This is a geometric sequence. Because we have a common ratio. If we take 6 over 3, that gives us 2. If we take 12 over 6, that gives us 2. If we take 24 over 12, that gives us 2. This is a common ratio, which means that our sequence is geometric, which is another type of number sequence. Now, knowing that this is not an arithmetic sequence and we don't have a constant ratio, we have a constant increase, we have a common ratio instead. What do you suppose the graph would look like? Do you think it would be linear? Let's go ahead and take a look at what. Here's the graph. Is it linear? No, it's not. It would not be a line because we don't have the constant slope like we did last time. It's not increasing by just a +4 or +3.5 or something like that. It's doubling every time there's a ratio, but that doesn't represent a linear graph. Now in number 4, you were asked to find the explicit formula, which ends up being 2 to the power of t times 3. This was the explicit. Now, where do these things show up in the table in the graph? Let's take a look again. The 3 in the graph is represented as the y-intercept. And we think instead about these being 3, and then 6 is 3 doubled, and then 12 is the doubled 3 doubled again, and then 24 is 3 times 2 times 2, and then that doubled again, and then the 48 comes from the previous step doubled again. Then you can see where that power of 2 comes in, and why 2 is the base, because it's the number being repeated, and then that base shows up the same number of times as how much time has passed. Just a couple more things to emphasize here. Notice as we come back to the graph, is this discrete or continuous? And which should it be? Hopefully you're answering discrete. Once again, because we shouldn't connect the dots, because it's not a constantly changing number of dots in between 1 minute and 2 minutes. It's just that at 2 minutes, the number of dots doubles. So we're not going to connect the dots and make this continuous here. Also, when taking a look at the explicit formula, it's important for you to be sure that you understand that when you're writing something like this, f of 2 equals 12, that means that the function after 2 minutes, or the situation after 2 minutes, has 12 dots. So if I said, what is the function after 4 minutes? You would say it's 48 dots. And so this t represents the time passed, or sort of like your x value, and then this ends up equaling the output of the situation, or kind of like the y value. Or this number here represents a member of the domain, and this number here represents the range. Again, this is domain and range. So here, the t represents the domain, and the 2 to the power of t times 3 represents the members of the range. And to summarize, this again was a geometric sequence, and a geometric sequence can be identified by the constant ratio between consecutive terms. So again, it has a constant ratio. And you will continue to work with sequences of numbers. Again, you need to be able to use tables, graphs, and equations, both recursive and explicit, to identify and represent both geometric and arithmetic sequences.